The second type of normal is the vertex normal. Each vertex in a mesh has a single vertex normal. These are used in combination with light sources in the scene to define the basic shading of a surface. Each vertex normal is calculated as the average of the face normals on each of the faces that share that vertex. Let's start with a cube and turn on the face and vertex normals. Since we're dealing with a two-dimensional screen, let's delete two of the faces and then change to front view. From this viewpoint, the vertex normals at the rear of the cube align exactly with those at the front, giving the impression that there are only 4 vertex normals, when in fact there are 8. But obscuring those back normals makes it easier to understand what's going on. Now we can clearly see that each vertex normal is at an equal angle to each of the corresponding face normals. And as we move a vertex, the associated face and vertex normals move appropriately. The final type of normal is the split normal. These are the main players in defining the shading created on a mesh's surface. Unlike the face and vertex normals, we can adjust the split normals, rotating them away from their default position. After any adjustment is made, they are known as custom split normals, or just custom normals. Every vertex has a set of split normals, with one split normal for each face that shares that vertex. By default, every split normal is parallel to its associated face normal. With the split normals in this orientation, each face is shaded evenly over its whole surface. This produces the flat face look. Now that we've briefly discussed the remaining normal types, we'll return to the Normals submenu, which we can reproduce as a pop-up menu using the key combination Alt-N. The next set of entries in the Normals submenu are used to adjust the position of these split normals and hence affect the surface shading. Looking at the partially complete model of an Art Deco radio, we can see a problem with the shading of its flat front surface. This is caused by the position of the split normals on the vertices of the two n-gons that make up the front. The next entry in the Normals submenu is Set from Faces. This resets the split normals belonging to a selected polygon to be parallel to its face, normal, and hence reinstates the flat shading. Rotate rotates one or more of the split normals of the selected vertices. This is an interactive operation, moving the split normals in response to mouse movement. As you can see, changes to each normal's location affect the shading of the faces using that vertex. Rather than initiate the operation from the pop-up menu, we can use the keyboard shortcut R-N. If we want to rotate a single split normal, we need to start by enabling both vertex and face selection. Next, we select the vertex containing the split normal. Then, holding down the Shift key, select the face associated with the split normal we want to rotate. Now, when we press R and N, only that single split normal will be rotated. The Rotate operation also creates a last op panel. The panel has the following fields: Angle, which defines the angle of rotation; Axis, which defines the axis about which rotation takes place; Orientation, which defines the axes set being used. The 3 Constraint Axis checkbox can be used to override the axis value above. During the rotation operation, the status bar shows what other keys can be used for further control during the rotation process. These are similar to status bar options we've discussed for other commands, so we'll skip a description of them here. An alternative way of rotating the selected split normals is to use the Point to Target option, which points the normals towards a specific location in 3D space. Typically, that location is the coordinates of the mouse pointer, the 3D cursor, or the object's own origin. Point to Target even has its own keyboard shortcut, Alt-L, which we can use to bypass the need to first display the Normals submenu. Which target is used is determined by pressing a specific key during the operation. The key options are shown in the status bar. Pressing M will point the normals towards the mouse pointer. The normals continue to move as we move the mouse pointer, only fixing their position when the left mouse button is pressed. Pressing the right mouse button cancels the option, returning the selected split normals to their previous position. Note that this is a sticky option, meaning that the M option will be selected by default the next time we use Point to Target. Pressing Ctrl and the left mouse button performs two operations simultaneously. It moves the 3D cursor to the location of the mouse pointer and makes the selected split vertices point to that location. Pressing O will realign the split normals to point to the object's origin. Pressing L points the normals to the object's pivot point. Usually, this is the object's origin, but remember we can adjust the pivot point in the Transform Pivot Point menu. For example, if we've previously set the pivot point to 3D cursor, pressing L will point the normals to the 3D cursor. Pressing I reverses the direction of the selected split normals. Pressing A aligns the selected split normals, making them parallel to each other. When we have the selected split normals pointed in some direction, pressing S will adjust that direction to lie between their previous direction and the latest one. When working with the Point to Target option, holding down the Control key and clicking on the right mouse button will extrude the selected vertices so that they are centered round the mouse pointer. Merge merges split normals on selected vertices. However, this only works if all the faces that share the normals to be merged have been selected. For example, if we want to merge all the split normals on this corner of a cube, then we need to select the three faces that vertex is attached to before performing the merge operation. However, in selecting these three faces, other vertices end up being selected, so the merge operation will potentially affect split normals on those vertices too. Split separates merged split normals into their original separate components, with each split normal parallel to its associated face normal. Split normals may be merged using the merge operation or by having specified smooth shading. As with merge, all the faces attached to the vertex on which this operation is to be carried out must be selected before the operation is performed. Note the double blue lines created around each edge involved in the operation. This indicates a sharp edge. Sharp edges are unaffected by the shade smooth operation. We'll have more to say on various edge types in a later video. The average entry is used to create a smoothing effect in the selected area of a mesh by creating a single split normal at the selected vertices. Once we select one or more vertices and choose Average, we are presented with yet another submenu. In that new submenu, selecting Custom Normals merges the existing split normals for each selected vertex, creating a single new split normal whose direction is based on the average of the directions of the original split normals. This will exactly match the direction of the single vertex normal. Face area adds a multiplying factor to each existing split normal based on the area of the face to which it is attached. This means that smaller faces have less influence on the direction of the new average normal. If we reduce the size of one of our two faces attached to our selected vertex, we can see that the new average normal favors the direction of the other face's split normal. Using corner angle, Blender takes into account the angles at which the vertex sharing faces meet when it is calculating the average split normal. We can see the result created by this option when applied to all the split normals of a modified grid. The difference between the three average options can be quite subtle, as we can see here, when we apply each to our grid. When we've been adjusting the split normals in any way, the Object Data page in the Properties panel will show a Clear Custom Normals Data button under the Geometry Data heading. Clicking on this button will return the split normals to their original positions.